Alright, so in this video we're going to be talking about both 0 and 1-step equations. Now the 0-step equation is something I don't think is often mentioned, but I think it's important to realize that with 0-step equations, right, what we're really looking at is the answer to an algebraic statement. So for example, if I said x equals 3, or x equals -2, or x equals 1/2. All of these are examples of 0-step equations. All that means is, in each of these cases, there's nothing you have to do. There are no steps required to figure out what the variables equal. Right? In the first one, you know x is equal to 3. That's what x is because you can just read it. Here x is equal to -2, and here x is equal to 1/2. So what we should really say is the goal of all equations is to ultimately reduce it down to a 0-step equation. So here's what we mean. Let's say you have x plus 2 equals 5. Well, here we're adding 2 to x. So to undo that, to work backwards, to create the 0-step equation, we subtract 2 from both sides. Here, 2 minus 2 is 0, and x equals 3. So we've reached a 0-step equation in one step. So this is an example of a one-step equation. And the one step we really needed to actually utilize is right here. We subtracted from both sides. So there are really only a few scenarios in one-step equations. In the first scenario, you have x plus a number. Let's call it a. And that equals some other variable, some other constant or number usually, like let's call it b. So the one step involved in this scenario is to subtract from both sides. And that's it. X will always equal the difference of b and a. If you have x minus a number, and it's equal to something else, x minus a is b, the opposite is true. You just add a to both sides, and you will be able to solve it. In this case, x equals b plus a. A number example that would look like this is, let's say you had x minus 5, and that equals 7. Well, here instead of a we have 5, so we add 5 to both sides, and x is equal to 12, right? So those are two scenarios you can deal with in one steps. When you're adding, you subtract a number. When you're subtracting a number from x, you add the number to both sides. If you're multiplying a number, let's say a times x, and that equals b, divide both sides by a, and that will give you the value of x, right? Here these a's cancel out, and x is equal to b over a. So an example in numbers, let's say we have 2x equals 10. Here 2 times something is 10, so if we divide it by 2, if we work backwards, we find out that x is equal to 5, right? These 2's cancel out. Because 2 divided by 2 is 1, there's no reason to write the 1 in here because we're multiplying by 1, and 10 divided by 2 is 5. So in a one-step equation where you're multiplying, you just divide to solve it. And in a one-step equation where you're dividing by a number, right, here you use the inverse operation, you multiply, right, to solve it. So the one step involved here is to multiply. These a's cancel out, and x would equal a times b, or b times a. So for example, if x divided by 2 is 10, we multiply both sides by 2, you can write like this, and x equals 20, right? 20 divided by 2 is 10. So in all of these cases, the one step you need to solve the problem is the inverse operation, right? If you're adding, you subtract. If you're subtracting, you add. If you're multiplying, you're dividing. And if you're dividing, you're multiplying to solve the equation. One thing to look out for is dealing with fractions. So for example, let's say you had 2/5 of x equals 8. And likewise, 2x over 5 equals 8. Now these are in fact the same thing, but I want to show to you that they are. Let's solve the one on the right first. So I'm going to multiply both sides by 5 to begin with, because I want to cancel out this denominator here. So we get 2x divided by 5 times 5. Those cancel out. And 8 times 5 is 40, so 2x equals 40, and x equals 20. So we solve that in two steps. Because we saw 2/5, we canceled out the fifths by multiplying by 5, and the 2 by dividing by 2. Here we can do the same thing, but notice that we can do this all in one step. And that one step is to multiply by the reciprocal. So instead of multiplying by 5 and then dividing by 2, we can solve this by multiplying the whole thing by 5/2. Mathematically, that's equivalent. Here, 5 halves times 2 fifths is 10 over 10, or 1, and x is equal to 8 times 5 divided by 2, which is 20. And you can see that these are in fact equal. So one thing to look out for is that you can turn a fraction coefficient into a one-step equation by multiplying by the reciprocal. We'll try one more. Let's say you have 3/7 x equals 14. Let's make it more interesting. Negative 3/7 x equals 14. You could solve this by multiplying by 7 and then dividing by 3, or by multiplying the whole thing by negative 7 over 3. And what that would get is x is equal to 7 times 14, or negative 7 times 14 is negative 98, right, over 3. And 3 goes into 90 30 times, goes into 8 twice, so this is equal to negative 32 and 2/3, right? So those are some classic examples of one-step equations. Hope this helped.